way back when we started the number sets, we started with the natural numbers and built up to the whole numbers and the integers and the rational and the irrational to make our set of real numbers. And every time we had to add to what we thought was everything, like the natural numbers, we had to add 0 so that we could accommodate nothing. Then we came across adding negative numbers. And we're like, huh, those are in there too. And then we added rational, and then we added irrational, and pretty soon we built up to the real numbers. Well, here we're going to get to a part where we get something like this: x squared plus 1 equals 0. And we try to find an answer to this equation. We're like, well, subtract 1. You're like, x squared equals a negative 1. Immediately you start thinking, wait a minute, is there any number that'll work? 1 doesn't work. 1 times 1 isn't negative 1. Negative 1 times negative 1 is also not 1. And so you're stuck here that there is no real answer, meaning this coming from the set of real numbers. So just like we did with negatives or with 0, we create a number to describe this answer. And the number, since it's not real, this is the name picked for, is imaginary, is going to be I. Now, I is going to be the square root of negative 1. And yes, we just made him up. We just created him out of nothing and said, this is what happens. This guy, when you square it, I squared will give you a negative 1. What an unusual thing, but that's where he came from. We needed something to solve this particular equation. Now you should note, so anytime we see this, we will make it an I. He adds and subtracts just like a normal variable would in an expression, which is kind of fun. But when you take him and these imaginary numbers and put them with the real numbers, so real and imaginary, and you put these two together, it's called, with two lines, the complex numbers. So a complex number could be like 5 plus 7i. That's 7 times this guy and 5 more. And just to give you a hint of where these guys are, if this is the real number line, okay, here's 0, here's all the positive ones, here's all the negative ones, I is not anywhere on this line. So even if we had 1 and 2, and here we had like the square root of 2 in there, and here's 3, and right there's pi, and so we get all these different real numbers, square roots, irrational, whatever we want here. I, shocker of all shockers, is not positive, because anything positive squared would be positive. It's not negative, because anything negative squared would be positive. And it's not 0, because 0 squared is 0. It turns out it's not on this line anywhere. He's up here somewhere. So this is actually, when you label it as such, this is the real, this is the imaginary axis. So I is right there. 2i would be right there. 3i, 4i, 5i. So 5 plus 7i is about up there. And all of these are unique individual complex numbers. We won't get too much into them, but we do need to know how to do arithmetic with these guys. So back to I. Let's make sure we understand. I is the square root of negative 1, and we'll always write I if it comes up. So if we have the square root of, say, negative 16, well, that's going to be the square root of 16 is 4, and the square root of negative 1 is I. So that is 4i. And this is how it works. 4i times 4i, when we times those two together, we get 16i squared. What is I squared? Negative 1. So this is indeed negative 16. 4i times 4i is negative 16. Kind of interesting how that works. So I squared is negative 1. This also means you would never, ever have a power of I bigger than 2. For if you did, like this, somebody gives you I cubed. What is I cubed? Well, that's going to be I times I times I, or I squared times I. What's I squared? Negative 1. I to the 4th. Well, that's I squared times I squared. I squared is negative 1. I squared is negative 1. So negative 1 times negative 1 equals 1. So that means if we have something like I to the 5th power, well, this is a grand thing to have. I to the 4th is 1 times I, that's I to the 5th. That gives us just I, because I to the 4th is 1. So let's say we get I to the 17th power. Well, I like I to the 4th being 1, because that's the multiplicative identity and goes away when I want it to. So I to the 17th would be I to the 4th, I to the 4th, I to the 4th, I to the 4th, 4, 8, 12, 16, 17. Shh. That all equals I. Isn't that cool? Let's do one more. Let's do like I to the 27th power. So this is going to be I to the 4th. I'm not going to write them all out there. I'm going to get 6 of those. That's I to the 24th. And it's going to equal, times I cubed. And I cubed was up here, negative I. So this is all 1. We get negative I. So every power will always simplify down to something less than 2. Either you'll get a number, a real number, I squared, which will be negative 1, an actual negative number right there, or it will be left with just a single power of I. Let's do one more to see how that works. I to the 30th. So again, this is the key on breaking it down really quick, along with these right here. That's I to the 4th to the 7th power, and I've got 2 left over. Okay, that makes 28. And so we, I to the 4th is 1 to the 7th, that's 1, and I squared is negative 1. So we have the answer right there. Some of you may like to do this with remainders. If you take 30 divided by 4, remainder 2, that's the answer. I'll do one more. I to the 5,384. No, that's too easy. I to the 5,381. Well, if you took 5,381 and you divided by 4, you would get, some number, remainder 1. And so this is going to be I to the 4th to something, I don't know what that is, but you have one guy left over. That all goes away to 1, and so it equals just I. And we'll always write I instead of square root of negative 1. There's your introduction to complex numbers. Now let's make sure you can add and subtract them. 2 plus 5i, and you're going to add that to 7 minus 4i. Well, 9 plus 1i. You're just going to combine like terms. So that's how addition and subtraction work, nothing new there. Multiplication is kind of interesting. 2 plus 7i times 3 minus 4i. These are binomials, so we're going to do that super distribution, or FOIL as some people call it. 6 minus 8i plus 21i minus 28i squared. And this is where we realize we're never going to have an I squared in an answer. I squared is negative 1. So this is negative 28 times negative 1. That makes it positive 28. So we have 6 plus 28 is 34. And we have negative 8 plus 21 is plus 13i. This is standard form of how we write stuff. A real number plus a real number times I. Now the last one, let's do division. So like 7 over 2i. Division usually comes about or is simplified and evaluated because I is a square root. And if you think back to how we rationalized denominators, we just got rid of the square roots in the bottom. So here we can times by something on top and bottom that will get rid of it on the bottom. We have 7i over 2i squared. What does I squared do? It's a negative 1. So we get negative, that guy's gone, negative 7 over 2i. The real part of this number is just 0. Let's do another one. 3 over 4 plus 5i. Now, when we do this, notice it's a binomial. And just like when we had to rationalize denominators that had binomials, the conjugate is going to play a big role. We're going to times by something that when we multiply it, we get rid of this I on the bottom, or square root on the bottom. And it's going to be the conjugate. This is called the complex conjugate because we are now in the complex numbers and we are taking the conjugate. 4 minus 5i, 4 minus 5i. Now, look at what happens here. On the top, we have 3 times 4 minus 5i. On the bottom, we have 16 minus 25i squared. Because we use conjugates, we don't have any middle terms going on in there. I squared makes that a plus. This is a negative 1, so negative 25 times a negative 1, that becomes a plus. So we get 16 plus 25 on the bottom is 41. And jump that in, we get 12 minus 15i all over 41. In standard form, we would have the real number 12 over 41 minus 15 over 41i. And that's the arithmetic of complex numbers.